So we've got this landfill, it's got all this solid waste. We are given an increasing function W. So, you know, all that's happening is waste is going into the landfill. They're not getting rid of any of it. And they give us a differential equation for it. dw dt is 1/25 of W minus 300. And first question is, use the tangent line to approximate the amount after 3 months. And so we need a tangent line. Right? So in order to find the tangent line, we need two things. We need a point and a slope, same things we always need. So the point should be 0, 1400. And our slope should be dw dt evaluated at 0, 1400, which the 1400 is a W value. So we'll have 1/25 of 1100. And oh geez, what is that? 44? 44. So your equation should be, and this is a y-intercept here, so if you wanted to just write it in slope-intercept, that's, you know, that's fine. Y equals 44x, or, well, 44t technically, because we're using t. 44t plus 1400. And then it says to approximate the value at 3 months, which is t equals 1/4. So we evaluate that at t equals 1/4. Looks like we should get 1,411. And that part was worth 2 points. First point was for getting the value of dw dt as 44. And the second point was for the answer of 1,411. So they didn't actually give you any points this time for the equation itself, just for finding the right slope and finding the value. Everybody good with part A there? Any questions on part A? Pretty straightforward after the ones we did yesterday, I hope. Okay. Part B, we're going to find the second derivative, which should be pretty straightforward after the ones we did yesterday. So our second derivative, we'll take the derivative of our first derivative, that 1/25. That's a constant, it's going to stay out there. And the derivative of W minus 300 ought to be dw dt. So we end up with 1/625 times W minus 300. Y'all agree with that? At home, you guys are good with that? Zoom, good?
Yeah, Zoom good.
Zoom good, good Zoom. Okay, and then we want to know if this is an underestimate or an overestimate. Well, the value that we're plugging in for W is always going to be more than 300, right? Clearly, because it starts at 1400 and it's increasing. So we can say this is always greater than 0 for all W. Well, we'll say for all t greater than 0, which is the situation we're looking at. That means that it's concave up, which means that a tangent line will underestimate it, right? We talked about that yesterday, right? And that was worth 2 points, 1 point for the correct second derivative and 1 point for the fact that it's an underestimate with a reasoning that the function is concave up. Yeah. Yep. Yeah, it says, in fact, on their scoring guideline, it says answer with reason. Even though usually what they want you to like, usually if they want a reasoning or an explanation, they say explain your answer. In this case, for some reason, they didn't. But if you're, always explain. If it's not just like a numeric thing that you're coming up with, explain why. Everyone good? All right, and then part C, we are solving the differential equation, which was what? dw dt equals 1/25 of W minus 300. And so once again, this is just a separable differential equation because the dw we have the W in the numerator there, and we have a W over here on the right hand side. So this will become dW over W minus 300 equals 1/25 dt. Everybody good there? We integrate. Left or the right hand side is just 1/25 t plus a constant. The left hand side, we do the U substitution for W minus 300. And what does that end up being? It should be natural log absolute value of W minus 300. Is that what you all got? People at home, that's what you got?
Yep.
Good. Then we find our constant when t is 0. Our initial condition was it 1400? 1400. So natural log of 1100 here is our constant. So we have natural log of the absolute value of W minus 300 equals 1/25 t plus the natural log of 1100. We will exponentiate to get rid of the natural log. And when we clear off the absolute value, we need to decide if we want the positive or the negative. Are we going to want the negative? We're going to have negative waste in here. No. So we want the positive. So we're going to have W minus 300 equals e to the natural log 1100 can be out front as a coefficient. And then we just add the 300. And that is our answer. Everybody go with that? Cool. Did we have to find a value? No, we didn't have. Sometimes they ask you to find a value there at the end, but in this case they did not, so don't have to worry about that. And then on the scoring for that one, it's 1 point if you separated the variables correctly. They gave you 1 point for both of the antiderivatives, 1 point for putting plus C, 1 point for using the initial condition to find your C, and then 1 point for finding W by itself. So 5 points there for part C. Everybody good with that? Any questions on that? People at home, you all good with that?
All good.
Great. All right. We got fish. How'd you guys do with the fish problem? Overall. We feel okay about the fish or no? Serena, not okay with the fish? Not a big fan of the fish? All right. Let's see here. I'm going to pull up the scoring guidelines for this one just so I can tell you here. Okay. So first question asked, we're given a couple of equations. One is E of t, which is the rate at which they enter the lake. One is L of t, which is the rate at which they leave the lake. Note that they are both rates, right? That's why I called these the rate FRQs, right? Because they are all about rate. So first question asks, how many fish enter the lake over the 5-hour period? The answer to that is just the integral of the rate at which they enter from 0 to 5. So this should be an integral from 0 to 5 of E of t dt. And you don't even have to write 20 plus 15 sine pi t over 6. You don't have to try to take the integral of 20 plus 15 sine pi t over 6. You have a calculator. This is a calculator question. Let your calculator evaluate the integral. Write the integral 0 to 5 E of t dt, and then write the answer, which is apparently 153 point something 45. And they say give your answer. In this case, they say give it to the nearest whole number because we don't have 0.457 of a fish. So we will say 153 fish. Does that make sense to everybody? So to get the amount that enter the lake, you integrate the rate at which they enter the lake. If you want the amount that leave the lake, you would integrate the rate at which they leave the lake. Okay. Integrate the rate at which people are leaving the Zoom meeting already. Apparently people are leaving. All right. Second thing we want to know is what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m. So we want the average number of fish that leave the lake. So how do we find the average number of something? This is the mean value theorem for integrals, right? Isn't that what that should be? Yeah, I would think so. So all we have to do is integrate the rate at which they're leaving and multiply it by 1 over b minus a. So, sorry, first part was, what was it? 2 points, 1 for the right integral and 1 for the final answer. So for part B, like I was just saying, 1 over b minus a times the integral from 0 to 5 of the rate at which they leave. And that should be the average number of fish that leave the lake in the 5-hour period. And I believe they gave you 1 point, 1 point for the right integral set up there. And then 1 point for the final answer, which was 6.059 fish per hour. So, all right, yeah. Yep. 1 for each of them. Yeah. No, that'd be fine. Yeah. They give a point for the integral itself, so they give a point for having that, and then a point for the final answer to indicate that you couldn't get that without dividing by 5 and stuff. Yep, that's fine. No. It has to be 3 decimals, yes. Yeah. Every single calculator question, if you use a calculator, do not round to less than 3 decimals unless they specifically tell you to. Like in part A, they specifically said nearest whole number, but part B, they did not say that, so you must round to 3 decimals or more. So if you want to, I don't know. If you left it as 6.05903H, which is what it says in the scoring guidelines that it comes out to be, that's fine. But at least 3. Yeah. Sure. Everybody good there?
Why do you multiply by 1/5 again?
That's the mean value theorem for integrals. 1 over b minus a times the integral from a to b of your function. Mean value theorem for integrals gives you the average value of a continuous function. Good or no?
Yeah, thank you.
All right, part C. Okay, so in parts A and B, usually if you get a rate question, part A is going to be very similar to this part A was, right? Pretty straightforward. You just integrate one of the things and put an answer. Sometimes they ask about average values. That's what we got in part B. They will usually ask you something about like the greatest number of fish in the lake or the greatest number of people on the escalator or, whatever it might be. So how are we going to find the greatest number of fish in the lake? Right, we want the derivative. We want the derivative of the function that represents number of fish. We want the derivative of the function that represents the number of fish to equal 0, right? Because that's when we can have a max or a min. Is if the derivative of the thing we're looking for the max or min of equals 0. True? Would you all agree with that? So the function that represents the number of fish that are in the lake should be the integral from 0 to, we'll say 0 to t of the number that enter minus the number or the rate at which they're leaving, right? So if we integrate from 0 to t, e of x minus L of x, that should tell us how many fish are in the lake, right? Integral of e of x tells me how many enter the lake. Integral of L of x tells me how many leave the lake. So the difference between them should be the number of fish in the lake. irregardless of how many started in it, because it doesn't give us an amount that started in the lake, right? Everybody agree with that? Y'all see that? So what's the derivative of this? Well, the derivative of this is just what's the derivative of this? It's just E of t minus L of t. Right? That's all that is, right? We just need to see when that's equal to 0. Yeah. I just changed, sort of like normally I write these as t's when I have x's over here. When my whole problem's in terms of x's, I change these to t's so the variables are different. Same thing here. Everything in the problem was actually in t's, so I just chose some other variable. Doesn't have to be x, it could be anything you want it to be. But your variable within the problem should be different than a variable within your limits of integration. Yeah, that's the only reason. Everybody good with this being the setup to find that? Yeah. All right. So that effectively then is saying graph E of t minus L of t and see when that has an x-intercept, or it's saying graph E of t and L of t and see when they equal each other. Right? Either one would work. You all agree with that? And that's why you have a graphing calculator for this, so that you can graph both those functions and see when they intersect. And it looks like they intersected at t equals 6.20356. That's the value you guys got, hopefully. And we need to show that this is a max and not a min, or that's for a max, right? Greatest number. So we need to show that this is a max, not a minimum. And so the best way that we can do that, there's a couple different ways we could do it. One way is with the sign chart, right? So we can say, here's our value at 6.20356. We just need to figure out how many fish are in the lake to the right of that and to the left of that, or figure out if the rate, E of t minus L of t, is positive to the right of that or positive to the left of it. So we can plug in something to the right of 6, like 7, to E of t minus L of t, and see what we get. And if you plug in something like 7, you're going to get a negative value, which tells you that the function is decreasing. And if you plug in something to the left of that, you're going to get a positive value, which tells you the function is increasing. And therefore, you have a max at 6.204, I guess. Is that what that rounds to? I can't tell if I wrote a 5 there. So, yeah. And did it ask what? So does it say what? No, just at what time is it? So, yeah. So you'd show the work. You'd show what E of 7 minus L of 7 is, and you'd show what E of 6 minus L of 6 is. You'd show that one's positive, one's negative, and therefore it's a max. Does that make sense to everybody? People at home? Oh, there's a question. Yeah, so the way I got E of t minus L of t is I said that so ignore this for a second. A function that represents the number of fish in the lake is the integral of E minus L. Right, so that's the function that represents number of fish in the lake. So to figure out when that function is at a max or a min, we take its derivative. So we take its derivative, that's the d dt. And this is just the first part of the fundamental theorem of calculus. The derivative of the integral from a constant to a function is, or from a constant to a variable, is just that function in terms of that variable. So that's just the first part of the fundamental theorem of calculus to get E of t minus L of t. That makes sense? Yeah. Okay. Cool. And how many points was this? This was worth 3 points. So 1 point if you set this equal to 0, 1 point for this answer, and 1 point for the justification. And you would need to show, like E of 6 minus L of 6 is greater than 0, and you would need to show that something like E of 7 minus L of 7 is less than 0. Another option that you could use is you could say that And once you found this value, you could say that this is the only place it could be a max, except potentially at the endpoint. And then you could find the number of fish in the lake at 6.20356, and the number of fish in the lake at 0, and the number of fish in the lake at 8. And so if you wanted to show it that way, you would plug in 0 to 0 of e of x minus L of x. Well, that'd be 0, right? We're plugging into our function that represents the number of fish in the lake. We could also do the integral from 0 to 6.20356 of e of x minus L of x. And that comes out to be 135 point something. And then you would also do 0 to 8 of e of x minus L of x. And that comes out to be 80.91999, something like that. And so you'd see that the max, which could only occur at the endpoint or a critical value, must have been at this value, because that was the largest number we got when we plugged it into the function that represents the number of fish in the lake. Does that make sense? No. Yeah. Leopold, you're good with that? Okay. All right. Was there a part D? I think there was a part D, right? Is the rate of change in the number of fish in the lake increasing, or is it decreasing at 5? Okay. So we want to know if the rate of change is increasing or decreasing. So what's the rate of change of the number of fish in the lake? Anybody? What's the rate of change of the number of fish in the lake?
Derivative.
Should be E of t minus L of t, right? E of t is the rate at which they enter, and L of t is the rate at which they leave. So the rate of change overall ought to be E of t minus L of t. And we want to know, is this increasing or decreasing at t equals 5? Well, how do you determine if a function is increasing or decreasing? Look and see if the derivative is positive or negative. So we want to find out, is e prime of 5 minus L prime of 5 positive or negative? And I know you're going to look and say, oh gosh, that's a really annoying thing to take the derivative of, and that's an annoying thing to take the derivative of, but you don't need to, because you have a calculator, and your calculator will take the derivative and evaluate each one at 5 for you. Right? So let your calculator do that work. Math option, I don't even know, 6 or something like that. And so that comes out to be e prime of 5 minus L prime of 5 is negative 10 point something, 7228, less than 0. So we would say that it is, that rate of change is decreasing at t equals 5, and you'd say because its derivative is negative. And that was worth 2 points. 1 point if you made an attempt to do something with e prime and L prime of 5, and 1 point for the right answer with some sort of explanation. The derivative of it is negative, so it's decreasing. Any other questions on the fish? Everyone's good? All right, let's do the escalator. Did I give you guys all the points for the fish one, right? I gave you all the points for all of it. Run through. All right. Well, let's see. We'll take a look. First, we got a function R of t that represents people that are entering a line, the rate at which people are entering the line to get onto an escalator. Apparently, escalators have long lines or something. I don't know. So from 0 to 300 seconds, it's 44 times t over 100 cubed minus times 1 minus t over 300 to the 7th. Okay? And we are told how quickly they leave the line. Right? They're exiting the line at 0.7 people per second. And we know that at the beginning, there are 20 people in the line. Right? So lots of information here. If they give you an initial condition, you can be pretty certain that you're going to have to use it somewhere along the way. And, all right, so first thing is how many people enter the line for the escalator during the time period 0 to 300? Well, all we care about is people entering. So we just use the function that represents how quickly they enter the line, which is r of t. So we will just integrate r of t from 0 to 300. You don't have to integrate it on your own. You have a calculator. A calculator will integrate it for you. So that came out to be 270. Does that sound right to everybody? And that was worth just 1 point per part there. But hopefully a pretty easy point to get. Yeah. And I think I said in the last one, right, that's generally what the first part of any of these is you take your rate and you integrate it on some interval and you get an answer. Usually 1 point, sometimes 2 for the setup and the answer. All right. Part B says there are always people in line for the escalator. How many people are in line at time t equals 300? Okay. So in order to figure out how many people are in the line at t equals 300, we need to figure out how many people entered the line, right? So first off, we'll write this on a second page here. The number that enter should be how many? We just figured that out. Should be 270. And then there were already 20. Is that right? And then we also have the number of people that are exiting the line, right? They exit the line at what? 0.7 people per second. And we're talking about how many seconds? 300. So we just need to do 290 minus whatever that is. What is that? 210. Yeah. So it should just be 80. Does that sound good to everybody? Which, let's see here. They gave you 2 points for that. So 1 point if you considered the rate at which they were leaving, and 1 point for the final answer of 80 people. All right. Good? Okay. Any issues in Zoom on that? Everybody okay with that in Zoom?
Yeah.
All right, great. Let's see, it's part C. For t greater than 300, what is the first time that there are no people in line? So after t equals 300, nobody is entering the line for the escalator. Apparently nobody cares about the escalator anymore after 300 seconds. How do we figure out when there are no people in line then? Just need to take the number that we had in line at 300 and do what with it? Why would we add 300 to it? Oh, add 300. Yeah, okay. I got you. I see what you're saying. Sorry, my fault. I thought you were adding a number of people, not the time period. Okay, yes. So we have 80 people that are in the line. And we know that they're leaving at 0.7 people per second. So if we divide that by the 0.7, what does that come out to be? 114.286. And then we're talking a t value. So that's why you're saying we're going to add the 300, which was our first 300 seconds. So that'd be 414.286 seconds. Everybody good with that? And that one apparently was just worth also 1 point for the answer. Everybody good there with part C? Yeah? Everyone's good there with part C? Okay. What about part D? We've only got 4 points so far, so part D must be worth 5 points. Oh no. This was worth 2 points. Sorry. 2 points for part A. My fault. 1 for 270, 1 for the integral itself. I don't know why I thought it was just 1 point. So we have 4 points left for part D. Part D, at what time t is the number of people in line a minimum? So we need to write a function to represent the number of people in the line. So what is the number of people in the line at any given time? Should be the amount that started in the line, which would be 20, plus the amount that enter the line, which should be the integral from 0 to t of, what was the function, r? Right? So we'll say r of x dx. And then what do we need to subtract from that? The what? People that are leaving, which is 0.7 people per second, 0.7 t. Everybody good with that? That's the function that represents how many people are in the line at any given time. We want to know, when is this at a minimum on the interval 0 to 300, right? Specifically 0 to 300. Is that right? Yeah. So what do we need to do with this? We need to take its derivative. The derivative of 20 should be 0. The derivative of integral from 0 to t of r of x is just r of t. And this is minus 0.7. So we want to know, when does r of t minus 0.7 equal 0? And so you have a calculator, you'll plug in the function for r of t, and subtract 0.7 from it and see when that equals 0. Or you can graph r of t and you can graph y equals 0.7 and see where they intersect. Either one is fine. Everybody good with that? That should be a t value of, well, there was 2 of them. 33.013298. And another one of 166.574719. Everybody okay with that? Conceptually? People at home, are you guys good with that or no?
Yeah.
All right. Let's see, let's go ahead. And number 2, how come I don't integrate the function for people leaving? We just said that people that leave in part B was 0.7 times 300. If we wanted to, we could. The function itself is 0.7, so if we integrate that from 0 to 300, that gives you 0.7 times, or 0.7x evaluated from 0 to 300, which is 0.7 times 300 minus 0.7 times 0. Does that make sense, David?
Yeah.
Okay, yeah. Since it's just a, since the function itself is a constant, you can just multiply it by the time period. But if you integrate, it comes out the same. All right, so for part D, we've now found the 2 time periods at which it could be at a minimum. So all we need to do is figure out what the actual number of people in the line is at both of these t values, as well as at t equals 0 and t equals 300. So t equals 300, we know, right? T equals 300 was 80. T equals 0, we knew was 20, right? So we just need to then plug in 33 to this equation and 166 to this equation. I mean, you know, the full decimals, but plug those both in. So this gives you, at 33, it gives you 3.803 people. And at 166, it gives you 158. 0.070. So which one of those is smaller? 3.803 is the smallest of those four numbers we had, right? Checking the endpoints, right? Our endpoints were, like I said, 20 and 80. This is at t equals 0 and t equals 300. Right. So at t equals 3.803, we're at a minimum. And we want to know the number of people. So luckily we just found that it's this is the t value and the number of people is 3.80. And it's set to the nearest whole number, I think, right? So 4. 4 people. Does that make sense to everyone? And that was worth 4.1 for getting this. R of t minus 0.7 is 0. 1 for getting this value of 33 as a possibility. 1 for the answers of at 33 and 4 people. And then 1 point for your justification, which is you needed to show that you checked the endpoints. 0 had 20 people, 300 had 80 people, and that you checked at 166 and it was more than the value was at 33. So that's your justification, is that all the other values, all the critical values and endpoints are more than this other one. Does that make sense, everyone? Yeah. You cannot use a sign chart for this one because you have 2 different critical values. So like if you tried to put in your, what was it, 33 and 160, 166, right? You'd see, we know that we started at 20, you'd see that this was going down, you'd see that this was going up, and you'd see that this was going down. But you wouldn't know if this value at 33 was less than this value at the end or not, right? Because I'm decreasing to this and decreasing to this. So I know that this is 80, but we still have to figure out what the value at 33 is. That makes sense why you need a little bit more. You need to find the actual value. When you just have the, if you just have the 1, and I go decreasing, increasing, well, then I know that one's the minimum, or vice versa. If it's up and down, then it's max. Does that make sense? Right, then the value at 33. Right. Yeah. I don't know if you guys at home could hear. The question was, can you just do a sign chart? And the answer for this one was no, because the sign chart will indicate that this is a local minimum, but it doesn't necessarily indicate if it's more or less than the value of 80 at the end. So you have to actually find the value at 33. You could ignore finding the value at 0 and the value at 166 if you did the sign chart, and just say at the end it was 80 and at 33 it was 4. So clearly at 33 it's small. But you have to at least make some comparison between those two. Everybody good there? Any questions there on that one? How do we feel about the rates now? A little better? Better than you did when you sat down last night trying to do them? Hopefully. All right. Do we want to, let's see. Let's do this. I'm going to assign you another rate one to do tonight. So we'll do one more rate one tonight. Oh, the bananas. That'd be good. So we're just going to do problem number 3. We're going to do the banana problem tonight. Tomorrow's Thursday, is that right? We're in class again tomorrow. Okay, so we're going to do the banana problem tonight, followed by, there is a document called Graph FRQs. Most people don't like the Graph FRQs. You will probably not like the Graph FRQs. I don't know why it's taking so long to open. It's not. No, it is. Why is this? I don't know. That's all right. I'll open the PDF. Okay. You're going to try to do, and if you struggle through it, that's fine. You're going to try to do problems 1 and 2 from the Graph FRQs. Both of them are non-calculator. Okay. 1 and 2 from the Graph FRQs. You will not like the Graph FRQs. People don't like the Graph FRQs. You might like them. I don't know. Maybe you like them. But most people do not like the Graph FRQs. So that's what you're going to do tonight. Bananas and then graphs 1 and 2. Everybody good with that? Bananas, graphs 1 and 2. Those are the first 3 things we'll go over tomorrow in class. We can go over, I know somebody was asking about going over one more of the area volume ones today. So let's do that. Maybe. I'd like to do that. My computer is going a little slow this morning. I don't know why it doesn't want to load. But I opened it. So give us a second.